This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
Hello, I'm David Karsten. You may be unfamiliar with the term built environment, but it's commonly used in architecture, construction, urban planning and design to refer to places where people live, work and socialise. These settings can include buildings, cities and public infrastructure, as well as areas like farmlands, dammed rivers and open space. Today there is an increasing focus on the built environment and its global impact, with buildings responsible for 40% of the world's energy consumption and the built environment contributing around 42% of the world's annual carbon emissions. With the climate crisis accelerating, finding ways to create more sustainable infrastructure has become critical to the future of the planet. In this episode, I was joined by architect, researcher and lecturer Zaid Osama from Curtin's School of Design and Built Environment. We discussed what we can learn from the world's most sustainable buildings, the impact of new digital technologies on architectural design, construction and operations, and how Perth's latest projects could see the city become a global leader in sustainable architecture. If you'd like to delve further into these topics and find out more about Curtin's research, you can visit the links provided in the show notes. Look, Zaid, I'm going to start with a very small and inconsequential question. With the world so focused on sustainability, how does architecture play a role in this? It's actually a massive question, isn't it?
It is. Well, the world is so focused on sustainability because the world is so concerned about the extremely rapid growth of the built environment and the consequences this has on the natural resources of the environment itself and its people. In fact, according to statistics and global research, the world's population is projected to be 9.7 billion people by 2050. 68% of them will be living in urban areas, and that means in the built environment, and this also means more infrastructure and more cities and more buildings to be built, of course, at the cost of the natural resources of the environment.
Well, just give us an understanding of that sort of impact. I mean, 9.6 billion people, Zaid, they've all got to live somewhere.
Absolutely.
They all need homes built for them. Maybe not all of them need homes built now, but there's a projected growth in building required. What sort of impact does an actual building have in terms of emissions and carbon footprint?
Mm-hmm. Well, it's a dual negative impact, unfortunately. From one side, for you to build the built environment, you need to consume resources from nature, including fossil fuels, including natural material, and so on and so forth. And this was one negative impact. The other negative impact is the emissions that those buildings and cities are posing on the ecological system as they are operating in their in-use phase.
That impact, as you say, is massive, but when we look at the numbers, that really drives it home. 40% of the world's energy consumption occurs within the built environment. Buildings are responsible for this. And of course, as you say, at the building phase, prior to inhabiting these buildings, we're looking at emissions of cement, iron, steel and aluminium are responsible for 15% of emissions. So at the construction phase, we're looking at a serious impact at that point. I know you've sort of covered this, but really 9.6 billion people needing somewhere to live and work. You have a massive task ahead of you to solve all of this on your own, Zaid.
Hopefully not. Look, to put this in context, it starts from the production of material. And if I give one example, is concrete and cement, which is one major component of concrete, on its own, emitting almost 7% of carbon footprint globally, just to make the concrete material. And then take it from production to transportation on site, and then from transportation to building that built asset, and from construction to the operation phase, which is the risky one, because in the operation phase, you will need massive amounts of energy to run these buildings and cities in some instances. And to do that, your main resource is fossil fuels. Your main resource is non-renewable energy in all of its kinds. And if you exceed the limit of using those natural resources, then you will harm the ecological system. And this is where you're going to see the climate change happening. And this is where you're going to see things changing around you really radically.
You talk about a dual negative at the construction phase and the operational phase, but typically, how long is a lifespan of a building? Can you talk to us about that? I mean, is there a sustainability issue with buildings attached to a finite lifespan?
Absolutely. Look, the lifespan of buildings depend on the typology of those buildings. So if we're talking about housing, then we are in a range of 30 years of lifespan. But if we're talking about skyscrapers and, major buildings, public amenities, hospitals, so on and so forth, then this is supposed to be 50 to 80 years of lifespan. In whatever case, you really need to have a holistic approach towards the planning, design, constructing, and operating those assets. And this is the only way you will adapt with the present needs of the, say, environmental challenges, and will also be able to be resilient and to be part of it instead of against it.
Well, Zaid, you're at the coalface. You're at the research side of this industry, of design and construction, but you are also, in a working context, part of an architectural practice. There are responsibilities incumbent on you to show us the way. Are there examples in play at the moment where perhaps the thinking is changing and that we are taking all of these issues into account and working that into our design future?
So I understand architecture as the craft of designing and constructing buildings and structures to achieve a purpose. This purpose might be functional, it can be societal, political, spiritual, symbolic, or all of them. There must be a purpose, David. That purpose has evolved throughout history. It has changed from the basic need for a shelter, which was the first representation of architecture in early ages. And then we've seen and witnessed a different form of architecture, which is showing glory and power. And this was in the first civilization ever, the Sumerian civilization in Mesopotamia, where I come from. Today's architecture and the purpose of today's architecture is to achieve sustainability. And in doing so, the UN Commission has defined in 2012 in the Rio de Janeiro conference what we call now Sustainability Development Goals. And these are 17 goals. I pick up goal number 3, 7, 9, and 11. Number 3 is about well-being and health.
Mm-hmm.
And this was in one way integrated into architecture and the current practice of architecture, where architects nowadays are tending to address human well-being in their designs, which wasn't really a concern in the 20th century, which was all about function and production and industry, right?
Yes.
Which really helped. And we've witnessed now many examples around the world where timber is the main building material. Sustainability development goal number 9 is about innovation and advancement.
Oh, that's always a magnet for architects, right?
Absolutely.
Always.
Especially on the city scale. This is where the concept of digital governance has emerged. And this is where governments around the world has moved their protocols from being traditional paperwork, so on and so forth, to becoming digital. All planning of cities, municipalities, so on and so forth, has become digital. And this is where we could learn why we are deciding on the built environment and such decisions, why we are designing and planning in such way, why not the other way. This is where we could also include people and participation in our planning of cities and the design of them. And that was another great move. And the last sustainability development goal that really impacted architecture in a way after 2012 is number 11, which is about sustainable cities and communities. Sustainability development goal of sustainable cities and communities has really shifted the practice of architecture towards more ecological designs, towards biodiversity, towards biophilia, towards living with nature and not consuming nature, not living on nature. Yeah.
Well, as architects, that's probably your biggest opportunity, your greatest opportunity to both, I guess, educate and also to have a real living 24/7 impact on people, because home is where it all begins, right?
Absolutely. Absolutely, you're right.
Well, Zaid, another great opportunity exists for you and your cohort, given that 3/4 of the infrastructure that we'll be using in 2050 is yet to be built. So have you and your cohort started taking that opportunity now? Are there examples that we can look at as a way of stepping forward in the right direction?
Definitely, David. I will give examples of different building typologies. So to give our audience a sense of what could be done for the future and what are the good examples. My first example is the Edge building in Amsterdam in the Netherlands.
The Edge.
Yes.
Ooh, sounds edgy, Zaid. What's edgy about this building?
Well, it's technology. Its technology is what edgy about it. So this building was designed by AFB Architects and was built in 2017.
So let's just for full context. This is the headquarters of Deloitte.
Yes.
Yeah. So it's an office building essentially.
Yes.
Yes.
It's an office building, and it's a 15-story building that is mainly used for office purposes. This example is about smartening the built environment. And to start with, this is a very clever prototype, David, that could show as a self-sufficient building, a building that doesn't require fossil fuels to run its operations. Another good thing about this building is the clever architectural design of it, the clever use of natural lighting, the clever use of ventilation, so on and so forth. So this really reduced the pressure on the mechanical systems of the building, say heating and cooling, lighting, so on and so forth, to consume more energy. And
so if I could just jump in there, that really is the simple principle of being north facing, right? and having a lot of glass on the north side, right? So that way you reduce the requirement for artificial lighting. You've got all that beautiful natural sunlight streaming in.
Exactly. Well, it sounds to be easy in a way, but it's hard to be implemented because you really need to have tangible calculations that would tell you whether this building is going to be self-sufficient or not. So it's not that easy in practice, I would say. But yes, you are right. These are the basic principles. Another thing about this building, its interconnection with its users. So once you arrive and stop your car in the car parking, then you are connected to the building. All the working spaces would be working in coordination with the users who are using those spaces. So, for example, if there are some spaces that aren't used, then the energy consumption of that place would shut down. So to, save more energy. And then same goes in the opposite way where another spot is being used, then lighting would work and so on and so forth for the heating and cooling system.
So how does a building know where you are, Zaid, at any one time?
Mm-hmm. So they have placed 28,000 sensors in this building, and those sensors are connected with what happens actually in the building in terms of what we call occupational behavior. So how users are using this building. So the building really continuously adjusts itself according to what is happening, and this is where we call a building a dynamic building because it's like a living body. It's not like a dead and static structure. It's a dynamic body that can adjust itself according to the changing conditions that happen inside it and also outside, actually.
Zaid, closer to home, is there an example that perhaps showcases alternatives on a smaller scale for building design and construction?
Absolutely. So we are so proud, David, to have the C6 building approval recently being approved by the city of Perth. This is going to be the tallest mass timber building to be built in the world, and it's going to be in Perth. What is exciting about this development is not being the tallest building, actually, but being the tallest building that uses almost 40% of its structural component to be timber instead of purely concrete. This radical shift from concrete and steel, which are the conventional building systems, to timber or mass timber is so significant for many reasons. I start with the basics. Timber, as a natural material, is a bank of carbon. So it absorbs carbon and it keeps it in it for a long period of time. And in contrast to concrete and steel, which would normally emit this carbon footprint and give it back to the environment. So in timber, you have a less impact in terms of carbon footprint on the environment. Another important thing, which is the ability of making timber a renewable resource. If we look at concrete, for example, you need to produce it, right? And in order to produce it, you need cement, which is the main component of it. And in order to make the cement, you need fossil fuels and you need non-renewable energy to be able to produce that material, which is a chemical material. However, in timber, we can simply dedicate farms, we call it timber farms, by which we'll be able to produce the amount of timber required.
So just to clarify for the listener, that's pine trees in the building of this 191 metre tall building,
Yes.
50 stories. Yeah. And it's been calculated or forecast to require just under 600 pine trees for this design to work.
Yeah.
So it certainly is an exciting development, and somewhat it's almost looking back to look forward. We're going back to timber.
Absolutely. And this is the happy news. Look, I think driving the way and leading the world and showing examples that would radically change the industry is so important at this stage. And it is really a great opportunity for Perth to come to the global stage and be a leader in sustainability and sustainable architecture and sustainable built environment. And you really want to make use of this opportunity, and you really want to make use of what we call city branding. And city branding is where you have a special thing and you showcase this special thing to the world so the world come and visit you. And this by nature would positively impact your economy. So architecture can be a great way to what we call city branding and to bring a city to the global stage. And if you look at history and, throughout history, many cultures and many cities have really evolved around architecture and have really used architecture as their language and identity by which we are visiting those countries and cities nowadays, and we are impressed by the architecture that they've got. So take this concept and apply it on the current context and the current challenges that we're facing. Showcase a good example, have a prototype, and you will be on spot.
Solved. Zaid, we've solved it. Well, look, we talk about the construction of this building having, I guess, so much potential for showcasing, I guess, a renewable future. But the operation of this building is something we need to talk about as well. We talked before about the sustainability starting in the home. Well, we're going to have occupants of 200 apartments in this building living in a structure that has been constructed half of timber, that is operating apparently at a carbon negative rating. It's going to be contributing to, I guess, the energy grid, possibly. Is that a fair assumption?
Well, it's an assumption. We will know once the building is in operation. But to be fair, this building is revisiting the sustainability development goals that I've mentioned earlier, goal number 3, number 7, number 9, and number 11, because it is really providing a healthy environment for its occupants, which is sustainable development goal number 3. It is really affordable in terms of energy consumption, which is sustainability development goal number 7. It is innovative in the way it's being constructed in its construction system, and this is goal number 7. And it is really an example of a sustainable community, which is sustainable development goal number 11. So in a way, yes, this is an example of a sustainable development, revisiting the sustainability development goals that we've mentioned. And I think those are certainly achieved in this development.
Zaid, you're very excited about the prospect of this happening. The excitement is palpable. But what else is Curtin doing closer to home in this space?
Yeah, so on a smaller scale, we have the Legacy Living Lab, developed by Professor Greg Morrison, Roberto Menino, and other colleagues. It's a great exemplar of a circular building, which used material that's been recycled, basically, and then reused in the construction of the elements of this building, say the walls, roof, ceiling, so on and so forth. Despite being a small in size example, it is really an excellent prototype to showcase the world and to draw attention to it.
So again, just for fuller context for our listeners, this is a modular two-story design. It's
Yes.
in White Gum Valley, and it very much echoes the design of homes around it as the development continues around it. But yes, please carry on. We're talking about a circular economy, showcasing a circular economy in terms of its construction.
Mm-hmm. Yeah, so starting with, this is a building example, like you mentioned, that follows the existing typology of that neighborhood. So it's a continuous extension of what housing is in that area. However, the construction methods implemented in this typology are different. Methods including prefabrication, methods including modular construction, so making the element in the factory and assembling it on site. So it is really, again, a great example of a small scale, because look, David, you have to start from a smaller step. And this is the thing. This is a small but first step towards a bigger and more comprehensive developments. And it is really a great example that's been done by Curtin University.
Well, Zaid, alongside the Legacy Lab, you're also working on a very specific area of sustainability and future design. Can you talk us through your area of expertise? This is fascinating.
Thank you. Yeah, so currently I'm working on something called digital twinning. And digital twins are virtual copies of the built environment from which we can know what exactly happens in that built environment in terms of the energy being consumed, in terms of the occupancy behavior, in terms of the usability manner, so on and so forth. This information is foreseen to be the key and transformative methodology towards an adaptive and a resilient built environment.
So you use this digital twinning at the design stage. Is that correct, or while the building is in operation?
Well, it could be used in the planning, in the design, construction, and operation of the building. It has multi-layers and multi-levels, and depending on what stage you are in, you can implement this technology. But the very basic concept of it is that in order to drive informed decisions, you need to know what is happening actually in reality.
You need to see the future, Zaid. Is that correct? Is that what you're doing? Is it like a crystal ball for a building?
Yeah, this is what we call proactive planning and design. You are right. Yeah, so once you've got this information, whatever it is, related to energy, occupancy, usage manner, so on and so forth, then you would know what is actually happening and for what reason. And therefore, you can adjust your settings, your built environment accordingly, so to adapt with these changing factors, so to be less negatively impactful on the environment, so to be more positively functional, so to be more integrated and interconnected, if that makes sense.
Look, it does make sense. We need data ahead of time to make better decisions. However, can you paint a picture for us? I'm a visual sort of guy. How does this take place? Is it on just a computer screen, or are you creating a virtual reality world? How are you doing this?
Before diving into this subject, you need to know that it's not about planning for the future only. Actually, the change comes from adapting the challenges that the existing setting is facing and adjusting the existing setting to be resilient and to be integrated with those changes. I'll give you an example. Now, you're not going to build a new world. You have to know that. You're not going to build totally new infrastructure. What you need to do, what we all need to do actually, is to adjust our existing built environment, including the cities that we live in, including the urban areas that are highly dense of buildings and people, and including each and every individual building in that system, which we call the built environment. And then linking this with the digital twin. The digital twin is introducing itself as a technology of copying this existing built environment that is already built, not for the future, no, the one that is built now. I give you a tangible example. We used as architects to design building without really knowing why we are designing it the way we do, right?
Oh, my mind is blown, Zaid.
Well, not all of us, not all of us.
That was quite the revelation, and you've heard it here first.
Yeah, so generally architects used to fulfill a functional purpose or an aesthetical purpose. And in both scenarios, they are not necessarily aware of the implications of this design on the environment. What the digital twin is proposing in the area of architecture is studying what is being designed with information. So to come out with informed design decisions that would make sense instead of following the function or the aesthetics only. This is in architecture. Then another example in infrastructure planning and infrastructure engineering, which of course has a bigger and bigger impact. As cities are expanding now, and as we are building more houses and fulfilling the population growth requirements, are we really aware of the climatic changes that we are being responsible of without knowing? Not necessarily. Are we aware of the consequences of the expansions of our cities and of the volume of housing that we are doing? Are we aware of the consequences of that on the environment? So in the infrastructure engineering example here, David, digital twin can be so beneficial in what we call proactive planning and disaster management planning. So it gives us kind of simulative scenarios to, if something happens, then what would be the response?
Yes.
And in what format and in which methodology, right? So that approach on its own in regard to infrastructure engineering and city planning is also so significant when we look at it from the digital twin point of view and then linking it with sustainability and achieving a sustainable future. How would you achieve a sustainable future without really knowing what you are doing and without really basing and grounding your decisions on data and tangible analytics that would drive this whole process?
So what sort of data are you working with, and what are you creating for an existing building? Are you creating a model? Is it AI driven? Tell us more, Zaid.
Absolutely. Well, this is part of the PhD that I'm conducting now, and it's about what we call a human-centered digital twin. So in basic terms, I've developed a digital twin for the Curtin University campus. This digital twin is basically a virtual replica of the existing campus, including the buildings and the spaces of the campus. This digital replica is then connected to the users of the university campus. In a way, we studied what we call the form-function user interaction, or in simple terms, the usability manner, how Curtin University users are actually utilizing the facilities of the Curtin University campus.
So how long has this been active, Zaid? And are you implementing change? Are you making a difference through this digital twin?
Mm-hmm. So we are in the third year now of this PhD project, and we were successful in really involving quite a good amount of Curtin University users in this experimentation, where we could exchange data in real time, in live format, between the digital twin and between the users of Curtin University. This data was mainly about the users explaining what is happening in the Curtin University campus in real time. Now, imagine the mechanical sensor, right? The mechanical sensor would tell you measurable facts. And this is why we call this a quantitative study, because if you do it with sensors, then sensors would measure, say, humidity, air temperature, so on and so forth. I'll give you an insight of what is happening in reality. But we've taken it from another approach, what we call qualitative approach, where the user, in a way, is being introduced as a dynamic sensor in the built environment, where they could describe to us certain things, such as why they are using building X, not building Y, why they prefer this pathway, not the other pathway. And through that, we've got really interesting data suggesting improvements to the campus, probably, but also emphasizing on the good things that are happening, such as building, say, the library is functioning in an excellent way. It provides us with different kind of spaces and facilities, which makes it a dynamic building. This is a positive thing. So we know that the library is running successfully. See? But then there were other examples where, for example, users say that this pathway is so long and it requires kind of stopping points or more shading, especially in summertime. So to be more usable. See, we've got this data, and this data has now become part of our existing and future planning and design for the Curtin University campus. And take it from this example, which is the Ph.D., and then implement it on larger scale on cities and buildings and so on and so forth. You would find that the process of architectural planning, design, and building operation would become informative, would become evidence-based. And this is a very quick way that we can mitigate our negative impact on the environment, but at the same time being resilient and being adaptive to what is required either from the users or from the environment itself.
Zaid, is this just raw data that you're gathering, or are you then applying that raw data to a model? Are we seeing a walkthrough of the campus on your screen? How does all of this actually take shape as far as a digital twin manifesting?
Absolutely. So you can imagine the digital twin as a digital equipment. Data would come through the users and be illustrated on the digital twin, right? Data would be location-based information, would be descriptive information connected to the location, saying that, for example, hey, there is a problem in this elevator, it requires maintenance, right? In real time. And once you've got this data on the digital twin, you can react accordingly. See? So the digital twin is the equipment. It shows data, it illustrates data on its virtual, environment. And this different kind of raw data, yes, it's raw data that comes from the users because we don't know what they say or what they describe, would be later used to develop reactions. And I give one good example, which is why users using the facilities of the built environment in such manner, why not in another manner? I'm hearing their description of what is happening. And according to their description, I'm developing a framework for adjusting the existing built environment to hopefully enhancing its functional performance and energy performance as well, talking about sustainability, according to the description of the users who are actually using them.
You have a foot in both camps in terms of research, but also in industry. I'm imagining the architectural community is a fairly close one. Is there some excitement about the potential of your research and how it can be applied in a real-world setting?
Definitely. In terms of research, so far we managed to publish a book chapter in Springer and 2 other publications in a Q1 and leading journals. And of course, this gives you a great exposure to the global community in terms of what kind of research being done in Perth and Curtin University. In terms of the architectural community, being a practitioner in this field, I always tend to open this kind of methodological approaches in design and try to implement it with my team in what we are doing and designing. Recently, we are involved in designing the Baghdad pavilion. Baghdad is the capital of my country, Iraq, and there is a proposal of a pavilion to be built, really, and we are part of this competition. I'm trying to integrate what I've learned from the digital twin in terms of the usability manner, in terms of what happens in reality, in terms of form, function, interaction, and implement that in the process of the design, so to come out with more informative design decisions. And in terms of getting exposure to the wider community here in Perth, so far, I think I've done 2 exhibitions so far in the School Design and Built Environment in Curtin University campus. Those were public exhibitions where people and general audience have attended, and we've demonstrated what we are doing to them. And although the concept sounds to be quite new, but they were impressed by the positive implications such method would have or such technology would have on the future of the built environment, especially in terms of sustainability.
Zaid, as an architect, you're living in very interesting times with a lot of responsibility on your shoulders, and it's been really great to see the work that you're doing in actually meeting that responsibility. We wish you all the best in your future endeavours, in your research and in your practice as well. And we thank you very much for being part of the podcast today.
Thanks, David. Thanks for having me.
You've been listening to The Future Of, a podcast powered by Curtin University. If you've enjoyed this episode, please share it.